Hello everyone, welcome to the video lecture series for the subject compiler design. Now I am going to explain you people about the conversion of regular expression to NFA by using the Thompson's method. Construction of an NFA for a regular expression which always relies on three different aspects. Number one is input, number two is an output, and number three is a method. By begin with the parsing and its constitution sub-expression, I was focused to explain you people about the basic operations of NFA so that you can able to understand how this regular expression is actually converted into NFA. Now I have taken this input called A plus B, plus is an union operator here. As you all know how this NFA can be constructed, now it has a two state here, it is an initial state, this is an end state. Now A comma B, which represents A plus B in NFA. If you draw the same particular transition diagram in epsilon NFA, we have the parallel access methods of ending up this A plus B in an end statement. That is an end state. Now we are using this epsilons to move from one state to another state without passing any input, as epsilon is a null state. So let me take you to the next possible operations in NFA, that is AB. Now AB represents a concatenation method. Now the NFA for this particular AB represents that initial state which passes an A to the next state. Now there is a dot here which passes the present state to next state with the input called B, and it ends exactly here. Now this represents NFA for the concatenation input, that is AB. Now let us see how the same input can be constructed by using epsilon NFA. The same aspects, but the only one new input here you can see, that is epsilon. As I told you already, epsilon is a null state which is additionally have a state to be moved from one place to another place, and then the input has been passed and it ends exactly over here. So let me take you to the next possible approach, that is operation number 3, A star. The star represents closure here. Now here we have only one input, and this input represents exactly here. It is a starting state and also it is an end state. Now you can see how exactly it happens. This A is keep on accessing the same process until it stops. This is the diagram, that is a state transition diagram which represents NFA. The same process when we called up for epsilon NFA, how the same process reflects here. As you all know how this process is really started, there is a starting state and this is an end state. In between we have initiated two other states to make this A run again and again until it stops. Now A is passed from one state to another state. Again it is called by using this epsilon. I am again jumping from the present state to the previous state. Now A is called again present state to the previous state. Example, if I need to end up this particular process without calling A, I can use this starting state. I can end up this particular process by using this epsilon to the end state until I want this A to be stopped. So the basic principle here you can see here, the regular expression is a representation of tokens. But to recognize a token, it can need a token recognizer, which is nothing but an NFA. We are using the same NFA for the basic operation, so it can be converting a regular expression to NFA by using the basic principles. Now let me show you the basic operations with the example with one particular diagram. Now this particular state transition diagram, draw an NFA for a regular expression for the input A of A plus B the whole star AB by using the Thompson's method. Now let me show you the solution. There is a problem in the solution, I'll tell you at the end. Now see here, this is a solution. I started doing this diagram. Now this is an initial state. So we have an input called A that has been passed here. We are using number of epsilons here because we are drawing a state transition diagram using epsilon NFA. Now here I have moved from one place to another place to create a new state. So I have used this epsilon. Again we are using this A plus B. This is an union operator, so I have made it parallelly A and B. This is the representative of union A plus B. So this is the diagram I have already shown you. I have again telling you again about the same process. Here this is a state, I am moving to the other state. Here the backward direction, this is the other state. I am using this epsilon to do the same. Again A plus B ends up over here, followed by we have closure. Closure in the sense, again the A plus B is called again and it is end up over here. I have derived two different end up statement here. Now one is exactly here and another one is exactly after this input passed to it. This is exactly here. Now I'll tell you, this is the right direction and this is the wrong direction. Now we are going to call only A plus B again whenever it is required. That is an epsilon we have used to call this closure again and again. So I need to run only A plus B again. I don't want to call again the null statement which have an input called A which is ended here. So I need to call only A plus B. So this is the right method so that I can access the A plus B again. Now I am using this particular state without accessing A plus B the whole star. If A want to move to the another state, so this is the representation I can end up here. So I am using epsilon to end up over here. After this, we have the concatenation process, that is A and B. Now I am using the symbol called A, that is an input symbol which passes from one state to another state. Again B, which ends up over exactly here. So this is how A of A plus B the whole star and AB by using the Thompson methods can be constructed. So now let me go example number 2 to draw an NFA for a regular expression A plus B plus AB. Now you can see this is a solution. This solution represents the same process, but A plus B, there's a union. Again A, again AB, before that there is a plus. That means B plus AB. This is a union operator. We have two different union operators, so we have a parallel access. Now you can see this is a start state and I am moving with an epsilon. This is A. Again I am moving with an epsilon to end up this particular A. Now A is over. Again I am moving to this B. Again I am starting with this epsilon, moving B, again epsilon, moving to this particular end state. Again I am calling this epsilon to move the concatenation process of AB. As the question has, this is the concatenation process. Now I am moving the same process, that is, as you all know, A dot B, again epsilon, this is ends up over here. So possibly this is the exact process of drawing, state transition diagram from a given regular expression to an NFA by using epsilon NFA. Thank you.